This is Jack Jackson. In this video, we're going to be talking about probability and statistics in the 19th century. So first of all, let's review a little things about what happened prior to the 19th century. And some study of probability goes way back. Games of chance have been known for a long time, and some of rudimentary things have been known quite a ways back. Cardano and Pasquale published some earliest works on probability theory in the Renaissance. But really serious study into probability theory is said to be started in the 17th century with the work of Pascal and Fermat, which is considered to be the birth of the subject. Christian Huygens uh, published the first major treatise on probability in 1656. In the 18th century, we saw the study of probability was advanced, and some additional work was done in applying statistics. Jacob Bernoulli in 1713 wrote Ars Conjectani, and Abraham de Moivre wrote The Doctrine of Chances in 1718, and they helped put probability theory on a solid mathematical foundation. Lagrange also published an important paper on probability theory in the late 18th century. So the subject had some start here and had a foundation to build on, and this was greatly expanded in the 19th century. So the 19th century saw major advances in the theory and application of probability and statistics. Legendre, in a paper he wrote in 1805, developed and published the method of least squares regression, which is extremely important. Karl Gauss showed that the power of least squares regression was very useful when he applied it to predicting the location of the dwarf planet Ceres. So the asteroid dwarf planet Ceres was found with telescopes and then lost. And so Gauss made use of least squares regression to look at the data that they had and use that to predict where Ceres should show up again in further observations. And it turns out he was correct and was much better than anyone else who had made predictions. And so that was the power of that statistical technique. Gauss also made use uh, of the normal distribution, sometimes called the Gaussian distribution, in his honor, which is of central importance in statistics. He also developed the method of Gaussian elimination to solve the resulting systems of equations. Wilhelm Jordan, who lived from 1842 to 1899, improved Gauss's elimination technique and is now called the Gauss-Jordan elimination technique used with matrices to solve systems of linear equations. You're most likely studied that in high school algebra or pre-calculus class. If you've taken a class in linear algebra, it probably showed up there as well. Laplace wrote his Theorie analytique de probabilité in 1812. He summarized earlier probability work and expanded the tools for studying probability, including introducing moment generating functions, inductive probability, and hypothesis testing. He also proved the central limit theorem. He expanded the use of applied probability to social sciences, including things such as insurance, demographics, decision theory, and credibility of witnesses. Chebyshev introduced the concept of random variable. Quetelet used the normal distribution to describe his concept of the average man. He collected a lot of human biometric statistics, things such as weight, height, etc., but also he collected some human behavioral statistics. Galton applied Quetelet's ideas to plant biology, and he included work with correlation and hypothesis testing. Descriptive statistics and the use of statistical graphs were also increased in the 1800s through the work of Playfair and Nightingale. And Pearson introduced standard deviation and chi-square test statistics. So let's talk a little bit about some of these people just a little bit more. First, let's talk about Pafnati Chebyshev. He was born in 1821 and lived to be dying in 1894 in Russia. He had one leg longer than the other, which gave him a limp. He became fluent in French, which helped him in communicating mathematics because a lot of the mathematics was written in French and German, English, some other languages, Italian. And Russia became a major language as well, but being able to communicate in French helped a lot in conversing with French mathematicians. In 1837, he entered Moscow University. He worked at St. Petersburg University, but also spent a lot of time traveling in Europe making contact with other top mathematicians of the day. He rigorously proved many of the foundational portions of probability theory. He worked in statistics, multiple integration, Taylor series, number theory, working toward a proof of the prime number theorem. Had some progress there. Mechanics and orthogonal polynomials. Adolphe Quetelet was born in 1796, died in 1874. He was Flemish. His father died when he was 7 years old. He took a job as a mathematics teacher at a school in Audernay in 1813. He was a mathematics instructor at a college of Ghent in 1815. He was interested in music. He wrote a libretto for an opera with his friend Juvenal Dandelin. He earned his doctorate and with his dissertation on conic sections in 1819. He studied with Fourier and Laplace, and he became a professor of higher mathematics at Atheneum, where while he was there, he lectured on probability. He also visited observatories in France, Holland, Germany, and Italy, and used his knowledge there. Well, he went there specifically to observe those observatories because he wanted to set up a Flemish observatory, which he did in 1832. The reason why we're talking about him here is for the period of time between 1825 and 1835, he studied social statistics. He was the first to apply the normal distribution to something other than just using it as an error law. And he applied the normal distribution to biometric data from humans, height, weight, mortality, and other things. But he also looked at social behavior and for example, criminal behavior, and tried to apply the normal distribution to those social behaviors as well. He came up with this idea of an average man, the idea that we could have an average person that has, average weight, average height, average mortality, average criminal behavior, average social behavior, and so forth. He also came up with something we use now, the Quetelet index, or the body mass index, where it's the mass in kilograms divided by the height in meters squared. And if BMI is over 30, one is considered obese. So that's something that's used now. He also stimulated a discussion of free will versus determinism, and he organized the first International Statistics Conference in 1853. Francis Galton was born in 1822, lived to 1911 in England. He was a Quaker from a prominent Quaker family. His mother was the daughter of Erasmus Darwin and cousin to Charles Darwin, the famous biologist. His father was a banker, and he attended school in medicine. He toured Europe and decided to be an explorer ultimately. When he was in college, he changed his major to mathematics at Cambridge, but didn't finish the degree. He became financially independent upon his father's death, and at that point, he got to realize his dream of becoming an explorer. He explored several areas, especially in Africa. He became an anthropologist, and after the publish of On the Origin of Species, written by his cousin Charles Darwin, he became convinced that intelligence was due to genetics. And so he became the father of eugenics, which is the idea that you can control and influence human development through selective breeding. He was a statistician and one of the first to employ questionnaire and survey methods. He came up with this concept of regression to the mean, and he proved that a normal mixture of normal distributions is itself normal. He also worked with correlation and regression, and he did a study of fingerprints, noting that fingerprints don't change throughout age and that they are unique on the individual. He's also known for this Galton board here, where you drop where beads are dropped in here, and they bounce around through this as they're funneled into the top of this. At each time they hit a peg, they can go left or right with equal probability. And you can see the distribution that's formed, which is actually a binomial distribution. And it's modeled by a normal distribution. I have one of these in my office. It's pretty cool. I also want to mention Florence Nightingale. She was born in 1820 and lived in 1910, and she was English. Her family was on tour of Europe during her birth in Florence, Italy, hence her name, Florence. She was tutored in mathematics by J.J. Sylvester, famous English mathematician. And you probably know her as the founder of modern nursing. In 1849, she toured hospitals. In 1850, she trained as a nurse, and in 1854, she was a nurse during the Crimean War. The the conditions were horrible in the field hospitals or whatever that they had during the war, and she was ultimately able to improve sanitary conditions and reform the hospital system. Um, she used collected data to back her healthcare reforms, and she was able to decrease mortality rate from 60% to 43% in 1 year in the hospitals with her uh, mainly insistence on keeping things clean. More people were dying from uh, dying in the hospital than they were dying on the battlefield. She increased fresh water and fruits and then eventually dropped the mortality rate to 2.2% in these hospitals. So that was a remarkable improvement there. And the reason why she's being mentioned here in relation to this history of mathematics is she was uh, a very early user and creator of some different kinds of statistical graphs. She created a polar area diagram, as the one you can see here. In 1858, she was the first woman to be elected to the Royal Statistical Society, and she even consulted with the U.S. military in the U.S. Civil War. And finally, for this video, let's talk a little bit about Karl Pearson. He was born in 1857 and died in 1936, so his work was in the late 19th century and it went on into the early 20th century. He was from an upper middle class family and he won a scholarship to King's College in Cambridge. There he was taught by Stokes, Maxwell, Cayley, and Burnside. He fought to get his attendance at divinity lectures in chapel made non-compulsory, but continued to attend those things. He had faith himself, but didn't feel like it should be forced on other folks. He graduated from Cambridge in 1879. He was number 3 in mathematics, what they would call the third wrangler in mathematics. He studied diverse subjects while he was in school and then afterwards. He ended up studying a wide range of things: physics, metaphysics, physiology, law, history, medieval and Roman studies, literature, philosophy, socialism, engineering, and mathematics. He actually passed the bar, uh, so he was able to practice law, but decided not to do that. At 33 years old is when he started working on statistics. So a lot of mathematicians do a lot of their best work when they're fairly young. Uh, he waited till 33 years old before he even started working on statistics. But that's where he made his most substantive contributions, were in statistics. He was influenced by Galton's work. He became a biostatistician. He studied heredity and evolution. He co-founded a statistical journal with Weldon and Galton called Biometrica. He introduced the concept of correlation, and he was pioneering and advancing interest in statistics. So he is definitely one of the fathers of statistics.